Imagine taking something heavier than our entire sun and crushing it down until it fits inside the city limits of Manhattan. That's a neutron star. And as of 2026, we know these objects are even more bizarre than we ever thought possible. A single teaspoon of neutron star material weighs 4 billion tons. That's heavier than every single human on Earth combined. On one spoon, these cosmic monsters spin at hundreds of rotations per second, have magnetic fields a trillion times stronger than Earth's, and temperatures reaching 6 million degrees. By the time you finish this video, you'll understand why neutron stars are the closest thing to science fiction that actually exists in our universe. And trust me, the reality is way wilder than any movie. Let's start with the most important question. How do you create something this extreme? Neutron stars are born from violence, specifically from the death of massive stars in supernova explosions. When a star between 8 and 20 times the mass of our sun runs out of fuel, it can no longer support itself against its own gravity. Everything comes crashing down. In less than a second, the core of the star compresses from something the size of Earth to something the size of a city. A second, that's faster than you could snap your fingers. This creates a shock wave so powerful it blasts the outer layers of the star into space at 15,000 kilometers per second. That's 5% the speed of light. For a few weeks, that dying star outshines entire galaxies containing hundreds of billions of stars. In 2026, our telescopes have detected supernova explosions from across the observable universe. But what's left behind in the center is even more remarkable. A sphere roughly 20 kilometers across, containing 1.4 times the mass of our sun. To understand how ridiculously dense this is, let me give you some perspective. If you could bring a chunk of neutron star to Earth just the size of sugar cube, it would weigh 100 million tons. That's more than every car, truck, and airplane on Earth combined. The gravity at the surface is 200 billion times stronger than Earth's gravity. If you dropped an object from 1 meter above the surface, it would hit the ground at 7 million kilometers per hour. This gravity is so intense, it actually warps space-time itself. Light from the back of the neutron star bends around it, meaning you could theoretically see both sides at once. If you somehow stood on a neutron star, which you absolutely couldn't survive, you'd be flattened to less than a millimeter thick before you even knew what was happening. The surface itself is smooth. Not smooth like glass. Smooth to within a fraction of a millimeter across the entire star. Any mountain higher than 5 millimeters would collapse under its own weight instantly. Now let's talk about what's actually inside one of these things, because it gets even weirder. The outer crust is made of iron nuclei packed together so tightly that electrons are crushed into the protons, turning them into neutrons. This is matter in a state that simply doesn't exist anywhere else. As you go deeper, the crust becomes harder than diamond. In fact, as of 2026, scientists calculate it's the strongest material possible in the universe. Nothing could be harder. Below the crust is an ocean of superfluid neutrons. Superfluid means it flows without any friction whatsoever. If you could stir it, it would spin forever without slowing down. And at the very center, the core, we honestly don't know what's there. The pressures are so extreme that normal physics breaks down completely. Some scientists think the neutrons themselves break apart into their constituent quarks, creating what we call strange matter. Others think something even more exotic might exist. There's even a hypothesis that the core might contain stable strange quark matter that, if it escaped, could convert all normal matter it touches into more strange matter. Don't worry though, that's extremely speculative and there's no evidence it's actually possible. But it shows just how much we still don't understand about these objects. The temperature on the surface is another mind-bending feature. We're talking 6 million degrees Celsius. That's hotter than the core of our sun. The surface of a neutron star is hotter than the center of a normal star. Let that sink in. At these temperatures, the star glows in X-rays and gamma rays. You couldn't even see a neutron star with your naked eye because almost none of its light is in the visible spectrum. But the most extreme property of neutron stars isn't their density, their gravity, or their temperature. It's their magnetic fields. When a star collapses, any magnetic field it gets compressed along with everything else. The field becomes concentrated into a much smaller space. The result is a magnetic field 1 trillion times stronger than Earth's. That's powerful enough to mess with the electron clouds of atoms from thousands of kilometers away. If a neutron star appeared halfway between Earth and the Moon, its magnetic field would erase every credit card, hard drive, and electronic device on the planet instantly. Some neutron stars, called magnetars, have fields even stronger, up to 1,000 times more powerful. These are the strongest magnets in the known universe. A magnetar's field is so intense that being within 1,000 kilometers would be fatal. The field would interfere with the electrical impulses in your nervous system and the molecular bonds in your body. These magnetic fields also do something spectacular. They create pulsars. As the neutron star spins, the magnetic field accelerates particles near the poles to nearly the speed of light. These particles emit beams of radiation like cosmic lighthouses. When these beams sweep across Earth, we detect pulses of radio waves. Some pulsars rotate hundreds of times per second, with timing more precise than atomic clocks. The fastest pulsar we found spins 716 times every single second. That's a 20-kilometer wide object spinning so fast its equator is moving at 20% the speed of light. If it spun any faster, the centrifugal force would overcome even the incredible gravity and the star would tear itself apart. In 2026, we've detected over 3,000 pulsars throughout our galaxy. Each one is a laboratory for studying physics under the most extreme conditions imaginable. Scientists even use arrays of pulsars as a galaxy-wide detector to search for gravitational waves from supermassive black holes. These dead stars are helping us map the structure of space-time itself. So that's a neutron star, the densest, hottest, most magnetic objects in the universe that aren't black holes. They're born in violence, packed with matter in states that can't exist anywhere else, wrapped in magnetic fields that bend atoms, and spinning at impossible speeds while burning hotter than the sun. If you found this absolutely mind-blowing, smash that like button and subscribe to your Space Wizard. We're making the universe accessible one cosmic wonder at a time. Neutron stars prove that the universe is stranger, more extreme, and more beautiful than we ever imagined. And we're just beginning to understand them.